Okay, hello everyone in the new video. So we have reached part 12 of chapter 7, which is the chapter of Newton's second law for grade 11 students. Before we begin, let me consider the following notes. So note number 1. So we know that the range is given by v square, v0 square sine 2 alpha divided by g. Here we are considering a projectile motion launched with initial velocity v0 and a shooting angle alpha. Now recall that the following property is sine 2x is equal to 2 sine x cosine x. So this is equal to v0 squared 2 sine x cosine x divided by alpha cosine alpha divided by g. Now suppose that we define the following angle, which is alpha is equal to pi by 2 minus beta. So we define the angle beta such that alpha is equal to pi by 2 minus beta. So now replacing alpha by pi by 2 minus beta, we got v0 square 2 sine pi by 2 minus beta multiplied by cosine pi by 2 minus beta divided by 2 divided by g, and we know that sine of pi by 2 minus x is equal to cosine x, and cosine of pi by 2 minus x is equal to sine x. So here sine and cosine are always related by pi by 2, so this is equal to v0 square 2 cosine pi cosine beta sine beta. So here what I have done, that this is given by cosine beta, this is given by sine beta, and this is equal to v0 square sine 2 beta. So here what we notice, that the range can be the same for two different angles that are given by alpha and beta, such that the relation is between them is that they are complementary angles. So in this case, what's the relation between alpha and beta? Is that alpha is equal to pi by 2 minus beta, which means that they are complementary angles. So what does this mean? Suppose here we have a projectile launched in the xy plane with an initial velocity which is given by v0 like this. Making an angle alpha with the horizontal. So the expected range, suppose it's something like this. So this is the range. Now launching the same projectile, which is, say for example S, so here we are launching a shell or an object. Now suppose that we launch it with the same velocity v0, but now with an angle given by beta. Now the value of beta is equal to pi by 2 minus alpha. Okay, so now pi by 2 minus alpha, so this angle beta, now the projectile in this case will have also the same range. Why? Now this projectile that have a shooting angle beta will have the same range as that of the shooting angle alpha, because simply that alpha and beta are related by pi by 2. Okay, so in this case we have alpha plus beta is equal to pi by 2. So because these two angles are complementary angles, then they will have the same range. Okay, so always the projectile have the same range for two different angles, so we can always reach a point which is considered the range by two different angles. These two different angles are related by pi by 2, that they are complementary angles. Okay, now the second note that I want to consider is the direction of the velocity vector. Now let's suppose in an xy plane also we have a projectile launched with an initial velocity v0 with a shooting angle alpha. Then this dotted line represents the trajectory of the projectile. Now let's consider this instant to be the instant t1. Then the velocity vector is represented at this instant by this vector v1, and v1, or let's suppose it's the vector v, which is tangent to the trajectory. V is tangent to the trajectory, which is the instantaneous velocity for the instant t1. Okay, and now we are interested in determining the direction of this velocity vector. Now this is the point of application of the velocity vector and not the origin. This is the origin O. At the point of application, just in order to simplify stuff, we have represented the xy plane. And if this is the angle alpha 0, this is the new angle alpha. What does alpha represent? It's not the shooting angle, however, the angle between the velocity vector v and the xy plane. Now alpha is the angle between v and the horizontal, and it is different than the shooting angle. Okay, so now in order to determine the direction, it's sufficient to determine alpha. In order to determine the direction of v, recall that v is a vector quantity. It has several properties, and they are given by the point of application, the line of action, the direction, and the magnitude. So the magnitude can be determined by v is equal to square root of vx square plus vy square. The point of application is the center of mass of the object, and it can be determined from the trajectory, which is the position. The line of action and the direction are determined by determining the angle alpha. So in order to determine the direction of v, it is sufficient to determine the value of alpha. So how do we determine the value of alpha? So now let's consider the following. let me project V on the x-axis, which is this, and V on the y-axis, which is this. Okay, so what does this represent? This is the x component of the velocity v, and what does this represent? It's the y component of the velocity v. Okay, and now if you consider the triangle A, B, C, now tangent alpha is equal to opposite over adjacent, which is equal, so this is the angle alpha. The opposite is given by CB, and the adjacent, so if this is the hypotenuse and this is the opposite, then this is the adjacent, then the adjacent is given by AB. Now if you look carefully, what does CB represent? CB is the value of Vy, and what is AB? AB is the value of Vx. Okay, so let me repeat the derivation one more time. So we are interested in determining the value of tangent alpha. Why? Because if we determine tangent alpha, then we will determine the value of alpha. So in this case, if you consider the triangle which is ABC, so if this is the hypotenuse, then this is opposite of alpha and this is the adjacent. Therefore, this can be written as BC divided by AC. Now the value of BC is Vy, and the value of AC is given by Vx. Okay, so it's sufficient to determine the value of alpha. Then in this case, tangent alpha for any vector v, which is the velocity for any velocity at any instant, tangent alpha is given by Vy divided by Vx, in which alpha represents the angle between V and the horizontal axis. Okay, now after we calculate the value of tangent alpha, so suppose that we have a velocity vector v given its x component and its y component, then we can directly determine the value of tangent alpha, which is given by Vy divided by Vx. After doing so, alpha is given by tangent minus 1 of Vy divided by Vx. Okay, so using the calculator we can determine this to deduce alpha in degrees or in radians. Okay, so now let's move to the exercise of this video, which is exercise number 16. And they are telling me a projectile S of mass m is equal to 20 grams, which is equal to 0.02 kilograms in the SI, is launched from the top of a cliff of height OH is equal to 20 meters. So this is 20 meters. With initial velocity vector v0 of initial speed v0 is equal to 10 meters per second, making an angle beta. So beta is the shooting angle, which is given by 30 degrees with respect to OX. So this is the origin O. In this case, x0 is equal to 0 and y0 is equal to 0, which is the simplest case of the projectile. Take g is equal to 10 meters per second square, which means that this experiment is being performed on the surface of Earth, and as expected, we are neglecting the resistance. Now, in number 1, they are telling me give the parametric equations of motion. And whenever they are telling me give the parametric equations, so give, no need to justify, we can directly list the parametric equations. So I expect that all of you must have memorized the parametric equations of motion that are given by x is equal to v0 cosine alpha t plus x0, vx equal to v0 cosine alpha 0, ax is equal to 0 for the x-axis, and similarly for the y-axis. But here, let's notice the following, that ax is equal to 0 because at any instant here, the weight is only acting vertically downward like this, and the acceleration ay is given by minus g and the minus sign because the weight is acting downward and the y-axis is chosen upward. Now if y-axis sometimes it's chosen downward, then in this case ay is simply given by plus g. Okay, now in this case we can directly say x is equal to v0 cosine beta t plus x0, but the value of x0 is 0. And so let me write it here, and Vx is equal to V0 cosine beta, and Ax is equal to 0, so this is 0. And as for the y component, we have y is equal to minus half gt square plus V0 sine beta t plus y0, this is 0. We have that Vy is equal to minus gt plus V0 sine beta. Previously we were calling this angle alpha, but now it's beta, so please we should use the same notation, and ay is equal to minus g. Okay, now let's replace some values. We have that v0 is equal to 10 and beta is equal to 30. So in this case, if we replace the values, we get that Vx, so x is equal to v0, which is 10 multiplied by cosine 30, so this is equal to 8.6060. Now no need to calculate Vx because simply Vx is the derivative of x, so t will disappear, and this is equal to 8.66 meters per second, and Ax is equal to 0. As for y, which is equal to minus 5t squared plus 5t if you replace the values, so if you replace minus half g and this, it will be given by this. Now in this case, Vy, no need to calculate values because the derivative of this is given by minus t, minus 10t, and this is given by plus 5. Always the derivative of the position is the velocity. The derivative of the velocity is the acceleration, and here in this case ay is equal to minus 10 meter per second squared. So notice that here I didn't place any unit because it is expressed in terms of another quantity. 0 doesn't need any unit, and in the case where it is constant, it is convenient to place the correct unit. So this is it for number 1. As soon as we have determined the parametric equations correctly, so we expect that the rest of the exercise will be just cakewalk. Now in number 2, they are telling me determine the trajectory. The trajectory equation is the relation between x and y. I prefer that you use everything in terms of the other variables. Then at the end of the exercise, at the end of this part, you replace the numerical values. Okay, so let me say that we have that x is equal to v0 cosine beta t, which means that t is equal to x divided by v0 cosine beta, and y is equal to minus half gt square plus v0 sine beta t. Now replace t and y, we get that y is equal to minus half g multiplied by x divided by v0 cosine beta to the power 2 plus v0 sine beta multiplied by x divided by v0 cosine beta. Now v0 goes simplifies with v0. This ratio give us tangent beta. Then y in this case is equal to minus half g 1 divided by v0 square cosine square beta x to the power 2 plus tangent beta x. Okay, and if we recall, this is the correct equation of trajectory for the case of projectile motion. Okay, so now we make sure that our calculation is correct, and we have that the value of v0 is equal to 10 meters per second and the value of beta is equal to 30 degrees. Now let's replace these values in the following equation. We have that y. Now plugging this fraction on the calculator as it is, let me calculate it. So we have minus 0.5 multiplied by 10 divided by 10 to the power 2 multiplied by cosine 30 to the power 2. So this will give us minus 1 over 15 x squared plus tangent beta, which is given by 0.58 x. Notice that in this case the value of tangent 30 is equal to 0.57735, etc. But I'm rounding to the second significance, so 7 is greater than 5, then this will be given by 0.58. Okay, and I will be rounding for the rest of this exercise to the nearest second significant. Now this is the equation of the trajectory. and let me write it here. And in this case, we need to deduce the trajectory described by S. So it is linear in one variable, quadratic in the other, so it is parabola. We are done with part 2. Now in part 3, they are telling me determine the range. So the range is dictated by this horizontal distance for which y is equal to y0. So this is the range. And this doesn't represent the range. Okay, so the range is given by definition for y is equal to y0. Now we need to determine the range, which is a horizontal distance. In order to determine a horizontal distance, which is x, we need to determine the variable t, and t can be determined by solving the equation y is equal to y0. Now, but notice that from the trajectory equation, y and x are directly related by the following equation, which is given by y is equal to minus 1 over 15x squared plus 0.58x. So no need to pass through time, because y0 is equal to 0, we can directly solve for the equation, which is given by 0 is equal to minus 1 over 15x squared plus 0.58x. Now how do we solve this equation? This is a quadratic equation in x. Either we can solve for the discriminant delta, or we can solve it by factorization. So taking x as a common factor, we have minus 1 over 15x plus 0.58. Now x equal to 0 is rejected because this corresponds for the origin, or we can solve this linear equation and the value of x is given by 0.58 divided by 1 by 15, which is equal to 15 times 0.58. Plugging this on the calculator, then the range is given by 8.7 meters. So this point here is labeled by the distance x is equal to 8.7 meters. So for example, the distance HP we expect must be greater than x, which is 8.7. Now this is it for part 3. They are telling me to determine the horizontal distance HP. So in order to determine the horizontal distance HP, which is x, we need to determine the value of t. But notice that also x and y are related by the following formula. So if we know the value of y, we can determine directly the value of x. Indeed, we know the value of y because this point here is described by the vertical distance, which is given by minus y is equal to minus 20 meters. Y minus 20 because y is a quantity which may be positive or negative, and it's not an absolute distance. Okay. So now referring back to the trajectory equation, which is given by y is equal to minus 1 over 15x squared plus 0.58x, we are interested in determining the value of x in which x is equal to HP, and this corresponds for the value of y, which is equal to minus 20. Now rearranging x, we have that minus 1 over 15x squared plus 0.58x plus 20 is equal to 0. So this is a quadratic equation in x. We need to go and solve for delta, or using the calculator, we have two values of x and they are given by x1, which is equal to, let me calculate it. So the value of x1 is given by 22.21 meters, and the value of x2 is given by minus 13.5 meters. And as expected, that this distance HP is being measured along the positive direction, so we expect that it must be positive. This is rejected and this is accepted. Okay. Moreover, y, this is rejected No, because it's negative. Okay, so we take the positive distance. So HP is simply given by 22.21 meters. Now in part 5 they are telling me determine the maximum height. So this is the maximum height reached by the projectile with respect to the sea level. So we need to measure this height with respect to the sea level. So we are interested in determining this height. So this height here is equal to the maximum height, which is h plus OH. So first we need to determine this maximum height. This maximum height is dictated by the equation Vy is equal to 0. After we solve for Vy is equal to 0, we determine the value of t. After we determine the value of t, we plug it in this equation in order to determine the value of y. Okay? So we are in part 5, solving for Vy is equal to 0, we get that t is equal to V0 sine beta divided by g, right? And this is tan multiplied by sine 30 divided by tan, which is equal to half, 0.5 seconds. So what does this represent? This is the time needed for the projectile to reach maximum height. But now, after we have reached the maximum height, the time needed to reach the maximum height, we can replace in this equation to find the value of y. So y, which is equal to minus 5t squared plus 5t, which is equal to minus 5 multiplied by 0.5 to the power 2 plus 5 by 0.5. Plugging this on the calculator, so this is equal to 1.25 meters. Then y is equal to 1.25 meters. What does this distance represent? This is the maximum height measured with respect to the origin. But notice that you are interested in determining the maximum height measured with respect to the sea level. So this maximum height measured with respect to the origin. So the maximum height measured with respect to the sea level is equal to h0 plus OH, which is equal to 1.25 plus this distance here, which is given by OH, which is equal to 20 meters. So this is equal to 21.25 meters. Then the maximum height with respect to the sea level is equal to 21.25 meters. We are done with part 5. Now in part 6 they are telling me determine the velocity vector of s at p. What does p represent? P is this instant, and the velocity vector is given by the vector which is given by v is equal to vxi plus vyj. Now we have determined vx and vy numerically, and they are given by 8.66i plus minus 10t plus 5 j. Now the velocity vector is equal to 8.66i plus minus 10t plus 5j. Then in order to determine the velocity vector at the point P, we need to determine the instant time t, which represents the position of the projectile at the point P, and this is given by y is equal to 20 meters. So did we determine this instant previously? So no. Okay. Then let's refer to this equation, which is given by y is equal to minus 5t squared plus t plus 5t, sorry. So minus 20 is equal to minus 5t squared plus 5t. Then we have that minus 5t squared plus 5t plus 20 is equal to 0. So this is a quadratic equation. In time we have t1 and t2, and time must be always positive. Minus 5, 20. So this is equal to 2.56 seconds, or t2, which is equal to minus 1.56 seconds. This is rejected because time is always positive. So now, after we have determined the instant time that represents the position of the projectile at the point P, plugging this value of time here, we get that V is equal to 8.66 I plus minus 20.6 J. Okay, and the unit of this vector is given by meter per second. Suppose that in this case you are interested in representing the velocity vector at this point. So the velocity vector will be something like this, which is tangent to the trajectory, which will be like this. Okay, now here they are not telling me to represent, but I'm doing it. And suppose that you are interested in determining, now this is an extra exercise or an extra part. We are interested in determining the direction, which is determining alpha. Then tangent alpha will be equal to Vy divided by Vx, which is equal to minus 20.6 divided by 8.66. Then plugging this on the calculator and finding the inverse of tangent, then it's given by shift tangent of the fraction minus 20.6 divided by 8.66. Then in degrees it's given by minus 67.2 degrees. Okay, so why the angle is negative? Because this angle that you are measuring here with respect to the horizontal, which is negative in the negative direction clockwise, so this angle is given by minus 67.2 degrees. Okay, so that's it for me in this video, guys. And the next part will complete solving exercises on the projectile motion.